we're asked to find the Laplace transform, which is a big F of s, of the function f of t equals e raised to the power of 2t. So applying the definition below, we have the Laplace transform of e raised to the power of 2t equals big F of s, which equals the integral from 0 to infinity of f of t, which is e raised to the power of 2t, times e raised to the power of negative st dt. And we're told that s is greater than 2. Notice in the integrand function we're multiplying and the bases are the same, so we can add the exponents. We can write this as the integral from 0 to infinity of e raised to the power of 2t minus st dt. And now because we have an improper integral, because the upper limit of integration is infinity, we need to write this using limit notation. We would have the limit, let's use the variable b, so as b approaches infinity of the integral from 0, because b is approaching infinity, we can replace infinity with b. And let's also write the exponent in factored form. Let's factor out negative t and write this as e raised to the power of negative t times the quantity. We'd have negative 2 plus s. Let's write that as s minus 2. And now for our next step, to keep things organized, let's find the in-def integral, then we'll come back and find the def integral, then determine the limit. So for our next step, we'll find the in-def integral of e raised to the power of negative t times the quantity s minus 2 integrated with respect to t. Well, notice how we'll have to perform u substitution, where u is equal to negative t times the quantity s minus 2. So differential u is equal to the derivative of this product times dt. Well, s minus 2 is just a constant. The derivative of negative t with respect to t is negative 1, so we have negative 1 times the quantity s minus 2 dt. So if we divide both sides by negative 1 times the quantity s minus 2, we would have dt equals, let's write this as 1 over the opposite of the quantity s minus 2 du. So in terms of u, we can write this as the integral, this would be e to the u, and again dt is equal to 1 over the opposite of the quantity s minus 2 du, which means the antiderivative in terms of t would be 1 over the opposite of the quantity s minus 2 times e raised to the power of negative t times the quantity s minus 2 plus c. But remember, our goal was to find the def integral and then determine the limit. So we can write this as the limit as b approaches infinity of 1 over the opposite of the quantity s minus 2 times e raised to the power of negative t times the quantity s minus 2, and the limits of integration are from t equals 0 to t equals b. So now we'll find big F of b minus big F of a, then determine the limit. Let's do this on the next slide. Well, notice how this fraction here does not involve b or t, so we can write this as 1 divided by the opposite of the quantity s minus 2 times the limit as b approaches infinity of e raised to the power of negative t times the quantity s minus 2. And now we'll perform our substitutions for t. So when t is equal to b, we would have e raised to the power of negative b times the quantity s minus 2, and then minus, when t is 0, we have e raised to the power of negative 0 times the quantity s minus 2. Well, as b approaches infinity, this term approaches 0, and here we have e to the 0, which equals 1. But to help us understand why this approaches 0, if we wanted to, we can write this as a fraction by moving the exponential term down to the denominator. So we could write this as 1 divided by the opposite of the quantity s minus 2 times the limit as b approaches infinity of, we can write this as 1 over e raised to the power of positive b times the quantity s minus 2 Again, this would be minus 1. Remember, we're told that s is greater than 2, so this quantity is positive, and b is approaching infinity, so the exponent on e is approaching infinity, which means the denominator of this fraction is increasing without bound, and therefore this fraction is approaching 0. So the limit is equal to negative 1. So we have 1 divided by the opposite of the quantity s minus 2 times negative 1. Well, we have a negative here and a negative 1 here, so this product would just be 1 divided by the quantity s minus 2, which is the Laplace transform of e raised to the power of 2t. So to summarize, the Laplace transform of e raised to the power of 2t equals big F of s, which we now know equals 1 divided by the quantity s minus 2. So going back to our first slide, big F of s is equal to 1 divided by the quantity s minus 2. And if you're entering this from the keyboard, it is important to put parentheses around the quantity s minus 2. As I mentioned in the last video, after we do a few of these, we won't find the Laplace transform of a given function using the definition. We'll use a table of Laplace transforms. So let's see if we can find the formula in the table that would allow us to find the Laplace transform of this function much faster. So here are just a few of the Laplace transform formulas. So notice how if the function f of t equals e raised to the power of at, then the Laplace transform of f of t, or big F of s, would be equal to 1 divided by the quantity s minus a, where in our case, we had e raised to the power of 2t, so a was 2, so we can quickly see that by applying the definition, we did find the Laplace transform correctly. It would be 1 divided by the quantity s minus 2, where s is greater than 2. I hope you found this helpful.